Okay, let's look at the homework 7.8, 7.9, problem number 8. Alright, so we want to switch the order of integration to evaluate this double integral. Alright, so let's do that. Alright, first we need to know the region we're integrating over. So let's just draw a picture. Here's the x-axis, origin, and here's the y-axis. Alright, so it looks like the bound, lower bound is y equals x to y equals 2. Alright, so y equals x is just a straight line, so it's going to look something like that. And to y equals 2, so it's probably somewhere around there, right? So that's the horizontal line, y equals 2. Right? Then x is going from 0 to 2. So x is 0, and I believe this is 2 right here. So this is 2. Right, so the region is we are looking at is this is the region, this triangular region. Alright, so we want to switch the order of integration, so it's still going to be a double integral and the same integrand, so it's e to the negative y squared, but we want to do it with respect to x and then with respect to y. Alright, so since we are integrating with respect to x first, we're fixing y. So fix y value, so here, just fix y. Then x value is going from x equals 0 to this straight line, which is y equals x or x equals y. Right, so looks like x goes from 0 to y. Right, then after that, to cover the entire triangular region, you can see that the y start from 0, then just keep on going until y equals 2. So it goes from 0 to 2. Right. Alright, then let's do integration. And what's first thing is that this is has nothing to do with x. So this is a constant, so we can place it in front of the integral, in the inner integral. So that's going to be, I'm going to go here. So integral from 0 to 2, this is left alone, and e to the negative y squared. Alright, now this is taken out, so antiderivative 1 would be just x. And it's going from 0 to y, right? Dy. Alright, so we're just going to get the integral from 0 to 2, e to the negative y squared. This is going to be just y minus 0, so times y dy. Right, then we can do a substitution on this guy. Let u be negative y squared. Right, then if you take the derivative of u with respect to y, it's going to be negative 2y. Right. Then take the reciprocal of both sides. You get the dy over du is equal to 1 over negative 2y. Right? Then multiply through by du. You get the dy is equal to du over negative 2y. And let's see, x goes from 0 sorry about that, it's actually y. Alright, let's see, y goes from 0 to 2, which means that the u is going from, let's see, negative 0 squared would be still 0, and to negative 2 squared is negative 4. Right? So we can rewrite this guy as integral from negative 4 to 0. Right? Then you have a e to the, we decided to call this guy u. So e to the u, and I'm going to leave y as it is, but the dy is du over negative 2y. Right? So we can cancel y on top and a y on the bottom. Then we can place actually we can probably use this negative sign to switch the lower limit and the upper limit. Actually, sorry, I messed it up. And let's see, where's the eraser? So it was actually from 0 to negative 4 initially, 0 to negative 4. Then we can reverse the order. Alright, so that's what I should have done. Alright, so what you get is, if you clean it up, you're going to have 1/2 is just a constant, so put it outside. Alright, so antiderivative e to the u would be e to the u, and you're going from negative 4 to 0. Right, so this is going to be, and 1/2, right, e to the 0 is 1 minus e to the negative 4. Right, so let's type this guy in. Right, so it's a 1/2 1 minus e to the negative 4. Right, let's submit for testing. Alright, it came back, and it looks like we got this one correctly. Alright, that's it. I hope that this was clear.